All right, guys. So when we're dealing with cosecant, remember cosecant of theta plus 45 plus 2. Cosecant is going to be the inverse, the reciprocal of sine. So we want to graph this one right here. And so we're going to take this sine function here and we're going to graph it. And so if we take the sine function, we know that sine is at 0, 90, 180, our normals. And we go 0, 1, 0, -1, and 0. So that's what our graph looks like. And we're going to take the theta plus 45, and we're going to set that equal to this value. There's no number out in front, so that's going to give us a 1. So that's 1 sine, not 1 sine, 1 times the y value plus 2. So if we kind of work with those, we'll just kind of work our way down here. If I do theta, so we're going to do theta plus 45 equals 0. So my first value is -45. So that's my phase shift. So my phase shift is -45. So if I look here, I've got to the right, no, left, 90, no. So right now, you can, by process of elimination, you could figure out that the answer is D. But if we kept going, we would do the 90. So we do theta plus 45 equals 90. We subtract 45 from both sides. This one's 45, and this one's 135, and so on. And then we would go from here, and we would look at this and say, okay, well, 1 times 0, this would be a 2. 1 times 1 plus 2 is 3. 1 times 0, that's a 2. And then 1 times that's a positive 1, and this would be a 2. So then these would all become undefined because that's where the zeros are because it's reciprocal. So we're getting cut at 135 degrees, and if you go, that's about 135 degrees right there. So there's all sorts of things you could do to solve these. We didn't do anything to the front of it, so the period's going to be 360 degrees. This one would have to been multiplied by 2 since it's 180. So that's how you tackle those there. Let's do the back here. Okay, so to set this one up, you've got this piece of information. First of all, we have sine is greater than 0. So it has to be in this quadrant or this quadrant because sine's the y value, so it has to be in quadrant 1 or 2. Then we know that the cotangent, which is adjacent over opposite, is negative. So that means that it has to be over here because it's got to be positive in this quadrant. So now we know that my adjacent is -24 and my opposite is 7. That's how you decide where the negative goes. It's got to be the negative over here. So we've got that piece. And then I'm going to do 7 squared plus -24 squared equals hypotenuse squared. And that's going to give me my hypotenuse that I need. And so we end up with, plug that into your calculator, and it looks like you get a hypotenuse of 625 in there somewhere. Yeah. 625, square root of 625, and the hypotenuse is 25. So we get that right there. And so that tells me that all my different pieces, opposite over hypotenuse is my sine, adjacent over hypotenuse is my cosine, and tangent is the inverse of the reciprocal of the cosine, which is that one. So we can plug in all those once we do that. The key to this is labeling it correctly and doing Pythagorean theorem. So we've got this one. We need to find cotangent. So we need to find cotangent, and this is our x and our y. So I'm going to go over root 17, and I'm going to go up 8. So if I do that to find my hypotenuse, I would do a squared plus b squared equals c squared, but they just want cotangent. which is adjacent over opposite. So adjacent over opposite is root 17 over 8, and that's why it's D. Okay? So just remember that that's a point. You make an X and a Y. All right, let's do this other one here. Let's reset it. Gotta be able to move this thing around here. All right, so let's look at this one here. We want the sine of theta if secant is 6 over 7. Secant is hypotenuse over adjacent, which is the same as cosine. So we can draw, just draw a basic triangle, and this is theta. So theta has a hypotenuse of 7 and a adjacent of 6. So we need to find the opposite, which is that right there. I don't know what that is. So we'll call that O for opposite. So we're going to go hypotenuse squared, 7 squared minus 6 squared is equal to the other side, O squared. So that's 49 minus 36, which is 13, O squared. So that means it's the square root of 13. So this is the square root of 13. And they want the sine, which is opposite over hypotenuse, so it's root 13 over 7. That's why it's C. This one here, remember, label it first. So theta's here, so this is going to be opposite. This is going to be hypotenuse. So that means I'm looking for theta, find the measure of each angle indicated, so I need to find theta. So opposite over hypotenuse is sine, so the sine of theta equals 4 over 15. And then if you do the inverse sine of theta, you end up plugging this into your calculator, because that's going to cancel, and I'm going to get theta. And I'm going to plug that into the calculator, and it's going to spit out 15.5 degrees. So don't forget, this is a key, the second sine function of your calculator. All right, so let's do this other one. Same thing here. Let's label everything. They give me this angle. So this angle is opposite. This angle's hypotenuse. So now I can set up my ratio, because sine, or so, is opposite over hypotenuse. So the sine of 55 degrees is equal to x over 3. That means the sine of 55 degrees, which you plug into your calculator, times 3, because I'm going to multiply both sides by 3. Those cancel, equals x. And that's going to kick out 2.5 degrees. Don't forget, you need to have your calculator in degree mode. Degrees. We need our calculator in degree modes. All right, so let's tackle this one here. So if I have 4 sine of theta, we're doing SAD/MEP. So PEMDAS backwards. I'm going to divide both sides by 4. That's going to give me the sine of theta equals negative 2 root 3 over 4. Those cancel, and I'm going to do that. And so where is the sine of theta? Negative root 3 over 2. So I simplified 2/4 to 1/2. And so now you've got to do, where is the sine of theta equal to negative root 3 and 1/2? Well, it's a 60 degree down in quadrants 2 and 4, so that's 60. So 180 plus 60 is 240. And then this one's 60. And you got to use the unit circle for that. That's 160 back from 360. So 360 minus 300 gives me, 360 minus 60 gives me 300. All right, so for this one, it's going to be a little more detailed. We have cosine squared and sine squared. So right now, since I have sine squared and sine, I want to get rid of this. So I'm going to say that this is 1 minus sine squared theta. That's our Pythagorean identity. And so then from there, I'm going to start distributing this and move this over. So let's just kind of clean this up. So we get negative 1 plus sine squared theta plus sine squared theta. plus 3 sine theta and plus 2 equals 0. Well, negative 1 plus 2, that's going to be 1. So, and I'm going to add those two together. So I'm going to get 2 sine squared theta plus 3 sine of theta plus 1, because negative 1 plus 2. That equals 0. So this is a factoring problem. I'm not sure how you factor. There's so many different ways, but I know that it's got to be 2 times sine, and it's got to be sine here. And so that means this is a positive. I got a plus 1 and a plus 1. So where is sine of theta equal negative 1/2 if I set this equal to 0? And where is the sine of theta equal to negative 1 if I set this one equal to 0? So this is going to be negative 1/2. That's going to be 210 and 330 because 1/2 goes with 30 degrees. Where is sine negative 1? Well, it's only negative down at the very bottom, down here, right? It's like right there at negative 1. So that's the 270 that we get right there. So that's why my answer is D. So if we tackle this one here, again, we got to do some math for that one. We're going to multiply by 2. Again, we end up negative 2, actually. I want to get rid of that negative also. So I end up with cosine of negative 2 theta plus 30 equals negative 2 root 3 over 4. So cosine of negative 2 theta plus 3 equals negative root 3 over 2. Now, where is cosine root 3, negative root 3 over 2? So we have two spots that it's at. It's at 150 and 210. So that you got to look that up on your unit circle. So we know that negative 2 theta plus 30 equals 150, and negative 2 theta plus 30 equals 210. If I do the math on this, I'm going to subtract 30 from both sides. That's going to give me 120 and divide by negative 2. So theta equals negative 60, which is not in between 0 and 360. So I've got to figure that out. And then if I subtract that, I get 180. And then if I divide by negative 2, I get negative 90. So I did 210 minus 30 divided by negative 2 gives me negative 90. And again, that is not inside that theta. So what do I add to it? Well, I know my period is divided by 2. So it's no longer 360. I'm going to add 180 to it. And that's going to give me my first answer of 120. And then I can add another 180. And that's going to give me 300. There's that answer right there. Now, the reason I'm adding 180 to it is because it's negative 60 and it's not between 0 and 360. And since I've put negative 2 theta out in front, my normal length is 260. My new length now is 180 because I get to divide 360 by 2. So it's not as long. So that's why I added 180 to both of those. And the same thing goes here. I'm going to add 180, which gives me 90. That's my first answer right there. And then I can add another 80, and I end up with 270, and that's where it goes. So you got to really pay attention to those. Those are the harder ones. All right, this last one here, we get negative 2 cosine squared theta, and I'm going to call this negative 1. Cosine 2 theta is 2 cosine squared theta minus 1 equals negative 2. Distribute the negative in, I get negative 4 cosine squared theta. Negative times the negative is a positive 1. And if I can't really move things around to one side and factor it. It doesn't do me any good. So I'm going to move the 1 over here, and I get negative 4 cosine squared theta equals negative 3. So I move the 1 over here. And then I'm going to divide by 4. So cosine squared theta, negative divided by a negative is a positive. 3/4. I take the square root of both sides. Cosine theta is equal to plus or minus root 3 over 2. Now, I'm going to go to the back of this here just so we can solve it. So we need to know where cosine, so right here's the answers, where is cosine equal to plus or minus root 3 over 2? Well, it's associated with 30 degrees. So if we look at that, this first one right here is root 3 over 2 and 1/2. So that's 30 degrees. That's my first answer. It's plus or minus, so I got to do this one. I got to do that one. And I got to do quadrant 4. So I need to take care of quadrant 1, 2, 3, and 4. When they're plus or minus, you're going to have all 4 quadrants. Well, this is 180 right here. If I go back 30, that's 150. If I go forward 30, that's 210. And this one, I go back from 360, and that's where my 330 comes in. Okay? All right. Let's tackle the last piece here, and we shall be done. So we are going to take our main ones, 270 and 360. You know what? I'm going to do it on the back side by the answer. So we got 4. Let's do 4 cosine 2 theta, theta minus 30 plus 2. Right? Okay, there we go. So let's look at this here. So we've got this piece here. So I need to use my points, 0, 90, 270, 180. Sorry about that, guys. 270 and 360. It's cosine, so start at 1, go to 0, down to -1, go to 0, back to 1. So I've got my 1s ready to go. So let's tackle that. So here we go. I'm going to do my y values first because it's going to be 4 times my y value plus 2. 4 times 1 is 4, plus 2 is 6. 4 times 0 is 0, plus 2 is 2. 4 times -1 is -4, plus 2, that's -2. 4 times 0 is 0, back to 2. 4 times 1 is 4 plus 2, that's back to 6. So if you notice, those two are going to be the same. Those two are going to be the same. All right, so now we got to deal with theta. Well, theta has a 2 pi minus 30 attached to it. So 2 theta minus 30 equals 0. I'm going to move the 30 over. Gives me 30 divided by 2. This first point is 15. So I just did 2 theta minus 30 equals 0. 2 theta equals 30. Theta equals 15. That's my first point. That's my phase shift. Phase shift, right, 15. Vertical shift, up 2. Minimum, maximum, 6 and -2. I'm just worried about the amplitude now and the period. So we can do all of these if you want to. 2 theta minus 30 equals 90. Add 30 over, it's 120 divided by 2 gives me 60. I'm going to add, this makes the difference of 45. So 45, 105, 45, 150, 195. What's 195 minus 15? That's 180 degrees. That is my period. It is the x maximum value minus the theta maximum value minus the theta minimum value equals 180. Or it's a lot easier if you look at the fact that it's 2 theta. 2 theta is equal to 360 degrees because we know that these are 360 degrees long. Theta is now 180 degrees. So that means my period is 180. So a bunch of different ways to look at that. That's how they come up with those answers. Remember, amplitude is just the number in front, and then you would graph it by using those pieces of information. Talk to you guys later.